All right, last homework problem for this first section of chapter 4. So this is homework problem 4. We're asked to find the maximum velocity for a grass line channel. Now we're told that it's 4 feet per second, and we want to find the maximum slope that can be used for a V ditch. So not a trapezoidal channel that is 1 foot deep, flowing full, and has 3 to 1 side slopes. So it's not a trapezoidal channel, but remember that we can use those trapezoidal channel equations. All we have to do is set this B value here, which is the bottom width of the channel, to 0. So the area becomes m times y squared. The wetted perimeter becomes 2y times the square root of 1 plus m squared. So it just lets those b values drop out since they're equal to 0 for a V channel. So for this one, and then we also know that it's a grass-lined channel, so we can go back to our Manning's equation chart here and say for grass-lined channels, we're going to have this 0.030 for n. But again, that would be given to you for a problem. Okay, so let's go ahead and solve for the area. Like I said, that would be my squared. In this case, we're told that the m is 3. And then the y value, it's 1 foot deep, so it's 1 foot squared. So our area is just 3 square feet. And then for our wetted perimeter, again, we're going to drop that b term, so we wind up with 2y times the square root of 1 plus m squared. So we're going to have 2 times 1 foot times the square root of 1 plus 3 squared. So we do that math, and that winds up being 6.32 feet for the wetted perimeter. And then remember that hydraulic radius is just that area divided by wetted perimeter. So in this case, the 3 square feet divided by 6.23 feet. And that gets us 0.47 feet for hydraulic radius. So now we're ready to plug into Manning's equation. Remember that we know velocity here, but we don't know slope. So let's go ahead and use that Manning's equation that solves for velocity. We'll use V equals 1.486 over n times hydraulic radius to the 2/3 times slope to the 1/2. We can plug in what we know, or we can algebraically rearrange it to solve for slope. I know that people are going to plug in what they know, so let's just go ahead and do that. So velocity is 4 feet per second. I'm just going to put that in as a number because my units are going to work out in the end as long as I put velocity in feet per second, and hydraulic radius in feet, and my slope as a decimal. All right, so we'll say 4 for that velocity, and that's 1.486 divided by this 0.030, and then r, that 0.47 to the 2/3 times s to the 1/2. And so I'm going to go ahead and move everything over so I have s to the 1/2 by itself. So I have 4 times this 0.030 divided by that conversion factor 1.486 and by that 0.47 to the 2/3, and that will all be equal to that s to the 1/2. All right, in order to unpack that, I'm going to square both sides, okay, and well, I'll tell you what this wound up to be. So that became 0.13358. I really took that out far. Equals s to the 1/2, and then I squared both sides. All right, and once I squared both sides, that means s is equal to, and I got 0.0178. But remember, we want to tell what that answer is in a percent. And so my slope is going to be 1.78% slope based on that given velocity.